Question. Solid cylinder of mass m, radius 2r is connected to a string through a frictionless yoke and axle. The string runs over a disc-shaped pulley of mass m, radius r. Mass m is attached to another end of the string and the cylinder rolls without slipping on the tabletop. Find the acceleration of the block after the system is released. So the question is very simple. We can go on making different equations of linear or translatory motion as well as the rotatory motion. Let us say the first equation I will make it for this particular body of mass capital M. So that will be using free body diagram. mg minus T1 is equal to ma. This is for this particular body. Now next equation we can work out the angular velocity of this body. Let us call it as alpha 2, and this rotation we can call it as alpha 1. So if I take this one as alpha 1, angular rotation of this body as alpha 2. So we can relate 2r into alpha 1 should be equal to r into alpha 2, or 2 alpha 1 should be equal to alpha 2. If I take alpha 1 as alpha, alpha 2 will be twice of alpha. Now free body diagram equation for this particular mass, this tension is T1, this tension is T2. So T1 minus T2 cross R should be equal to I into whatever the value of alpha 2 is there for this particular body. So let us make for this pulley. This is equation 1. This we got it as equation 2. Now for the axle, yoke and axle. T1 minus T2 into R should be equal to I into alpha. What is I? Because it's in the form of a disk, mr square by 2 into alpha. Alpha 2. What is alpha 2? 2 times of alpha 1, or I can write it as alpha. What is alpha? A by R. So we get it T1 minus T2 is equal to 1R we can cancel out, 2 cancel out, M into A. This is, let us call as equation 3. Now let us make an equation for this particular body. So here, because it is rolling without slipping, friction force will be there. T2 minus F is equal to M into acceleration. Equation 4. Now torque equation for this body we have about this particular point, or this point here, T2 into R should be equal to I into alpha 1, angular velocity of this particular body. So this is M into 2R square, mr square by 2 into, let us call this as alpha. So T2 can be written as alpha is A by 2. So this is M into A, fifth equation. Now substituting value of T2 in the third equation, what we are going to get? T1 minus T2 is equal to MA. So I'll substitute T2 as MA. T2 minus MA is equal to MA, or T1 will be equal to 2 times of MA. Now I got the value of T1. So once I know the value of T1, we can substitute in this equation. mg minus T1 is equal to MA. Now I know the value of T1, we can substitute here. mg minus 2MA is equal to MA. So we have 3 times of MA is equal to mg, or A can be written as g by 3. This is the acceleration of the mass m. A is equal to g by 3. So 2g by 5 is the wrong option, g by 2 is wrong option, g by 3 is the correct option, g by 4 is also wrong option. So correct option will be option C.